Welcome everyone. In this video lecture, we will solve a concept or we have to think a concept about voltage switch feedback. So in this concept presentation, we will think about the MOSFET amplifier stages in Cascade acts as a negative feedback, that is our voltage switch feedback. So here, as per the name, two amplifier stages, which is two transistor here, M1 transistor, M2 transistor, in which the drain of M1 is connected to the gate of M2. Okay, so here two MOSFET amplifiers are used, in which the output of the first amplifier is fed to the input of the second transistor, that is our M2. Okay, and we are taking the output from the drain of M2 transistor. So basically this one is our, you can say, this one is our drain of 2, gate of 2 terminal, source of 2 terminal. Okay, similarly drain of 1, gate of 1, and source of 1 terminal. Okay, so basically the output, this one is fed back to the this gate, okay, of F2 transistor, and we are taking output from the drain to in, and the output voltage V naught is sampled by a feedback composed of the voltage divider R1 and R2, two voltage divider R1, and the feedback signal VF is fed to the source terminal, that is our M1. So basically, if we redraw the circuit, the same circuit I am just drawing. So basically, what it is, this one is simply what we can say. There is a feedback network. Okay, I am selecting some different color. Okay, wait first. This one is nothing but simply a feedback amplifier, and the above one, we can say, the above one, this part, we can say, this one is our amplifier having some gain A, and this one is our feedback network, feedback network having some gain, that is our beta. Okay, so this one is source voltage, some input we are just giving, and we are taking output from this M2 in, and this is a voltage divider, okay, and R1 R2. So this one is the circuit. So now here this one is which kind of feedback is there. So for this purpose, if we apply Kirchhoff's voltage law in this loop, okay, in loop 1, it will give plus Vs, okay, starting from plus Vs, minus Vi, minus Vf equals to 0. So Vi equals to Vs minus Vf, and this one is nothing but simply our get to source of 1 voltage. This is very important line. Okay, means the input which we are giving across the amplifier is Vs minus Vf. So if this Vf is more, if this Vf, okay, if this Vf is more, okay, then the Vi will go reduce, so it is negative feedback, negative. Okay, so how this Vf is increasing, that we can think now how it is increasing. So before that, what we can say, for example, this output voltage I am saying this one is a V naught 1. Okay, so V naught 1, the output in the transistor M1, in general we can write minus G1 some RD1 into VGS1. Okay, VGS1 or capital VGS1 we can write. Okay, VGS1. Okay, so now this one is the output across this. Now if we go for the, and this one we can write as simply minus gm1 rd1 into vi. Now what we can write, now v note 2, the output, then output this one at m2 transistor will be simply, this will act as a input. Okay, so what we can write, minus gm2 rd2, and our input will be nothing but simply v naught 1 into m1. Okay, so this one will be a positive. Okay, so before that we have to write gm2 rd2 into minus gm1 rd1 into vi. Okay, simple cascade. So it should be gm1 gm2 rd1 rd2 vi. So here what we observed that as vs increases, okay, vs increases, v naught 1 at m1 transistor or drain of 1 voltage across the drain terminal of m1 transistor. Okay, this one is the simply we can write drain voltage of m1. Okay, drain voltage of m1. Okay, so this drain voltage of m1 will be decreased, will be decreased. Okay, decreased. Okay, because as vgs increases, this v naught 1 will be like this negative sign, so it will decrease. But on the other hand, v naught 2, that is our output, or we can write drain of 2 of m2 transistor, this one the m1 transistor, will be increased, increased. Okay, and vd2, because this one is a positive sign, positive one. Okay, so it will, this one will be increased. Okay, so simply we can say the v naught value will be increases. Okay, means this one is vs, then output negative, vd1 negative, and overall output v naught 2 will be positive. So now then after this beta, then this output voltage, this one is basically our V naught output. Okay. Now here the beta, that the feedback gain, that is our Vf by V naught. So Vf here, Vf equals to beta times of V naught. So here Vf will also increases because V naught is going to increase. So every time the Vf will increase. So the input one, that is our Vi, equals to Vs minus Vf. So as Vf increases, Vi will be lower down something as Vs is fixed. So this one is a negative feedback. Negative feedback. Okay, in addition to that, the Vf and Vs change in the same direction or same polarity. We can write same direction or same polarity, which verifying that, which verifying this one is a, which verifying find that the feedback is negative. Okay, so this one is the concept. Okay, means the first thing, that is our this vgs. Okay, this one vi equals to simply vs minus vf by applying this one, and this output, that is our v naught output, is just fed back to this. So now here the gain will be, if this for the AC analysis it should be grounded. Okay, so it should be simply minus gm1 rd1 vi, then this one is the input and we have to just gm2 rd2, and then it will go like, and beta will be Vf by V naught. So Vf equals to beta V naught. So every time V naught will increase. So this one is a example of two MOSFET amplifier which are connected in cascade manner. output is connected to the input of another. So this will give a voltage series feedback, and this one is a example of a negative feedback. So this one is a good example of a negative feedback. Okay, and I have taken this one from Microtronics Advanced Speed book. So thank you for watching this video.